This is 1.8, Statements of Logic. Now, this is a bit of writing in this, even if you shorthand it and organize it. So I suggest that you do that to make your lives a little bit easier. So organize these notes well, but please don't write down everything you see on the screen, or you're going to have a novel by the end of the video. All right, so we're getting into statements of logic, and before we do that, we have to understand what negation is. So the negation of any statement P is the statement not P. So for example, the negation of Twilight was a good movie is Twilight was not a good movie, which is actually very, very true. It was not a good movie. Sorry if anyone feels differently. The symbol for not P is this. So this tilde, that means not. Okay? So if we have a conditional statement that says it is not snowing, we would write that, for example, as maybe not S, or the negation of S. And the negation of the statement would actually make it positive. So just understand that sometimes your initial statement can be a negative statement, so you would start off with the tilde, and then of course when you negate it, it becomes positive. So it's kind of like with negatives and when you're working with numbers. It's similar to that. Now, every conditional statement has three other statements. A converse, which we covered, where you just kind of flip the two. So like if this is the first and this is the second, the converse, it would be the second and then the first. For an inverse, the order remains the same. So order is the same, but negate both. Okay, so we keep this initial order, but we negate both of them. And then for a contrapositive, you would flip the order, so reverse the order, then negate it. Okay? So let's take a look at this example. So find the converse, inverse, and contrapositive of the statement. If you live in Chicago, then you live in Illinois. So that's the initial statement. So if it helps, you could shorthand and say if Chicago, then Illinois. So the converse would be, if you flipped it, if you live in Illinois, then you live in Chicago. The inverse would be, if you don't live in Chicago, then you don't live in Illinois. And the contrapositive would be, if you don't live in Illinois, then you don't live in Chicago. Okay? Now, as you can tell from this, these aren't always true. Okay? For example, let's take a look at the Venn diagram that I have here. Okay, so Chicago is, and let me change the color on that so that you can see it a little better. We'll go with this here. So here's Chicago, because we all know Chicago's inside Illinois. And here's you. So the first one, if you live in Chicago, then you're in Illinois, which is absolutely true because Chicago's inside of Illinois. All right, so let's try the converse. If you live in Illinois, then you live in Chicago. Well, I've got an example right here where you could live in Illinois, but not in Chicago. Okay, and then there's the inverse, where if you don't live in Chicago, then you don't live in Illinois. And again, I could not live in Chicago, but still live in Illinois. So that would be false. And then there's a contrapositive. If you don't live in Illinois, then you don't live in Chicago. Well, that one's true. So the Venn diagram can help you. Some of them will make common sense, but the Venn diagram can help you when you're trying to figure it out. So theorem 3 states that if a conditional statement is true, then the contrapositive of the statement is also true. So basically, if we have if P then Q, you would also have if not Q then not P. So the contrapositive of a statement will always be true. Very important. Okay, this is something that you should write down. Okay, now chains of reasoning. These are kind of like leading you into proofs, because this kind of gets you thinking like, okay, I've got to show this, and I've got to kind of move from one statement to the other. So, steps that, as far as chain of reasoning goes, it's going to be like if P then Q, and then if Q then R, and then you could say, well, then if P then R, because what happens is, and it's easier to see when it's written vertically, because basically what happens is you have if P then Q, if Q then R. So what can I deduce from that? This means like hence or therefore. So notice how these are kind of diagonal from each other. For a chain of reasoning, that's what you have to do. And then when you get to the end, you have a start and a finish. And if you've done your chain of reasoning and your symbols match up, you can then say, well, if the first, then the last. So that's why that works, because if you've got it so that you followed the chain, then you can say if the first one, then the last one. Okay, and this is the chain rule, which is like a series of conditional statements, and it's connected, so we call it a chain of reason. So let's take a look at the second example, and it'll make more sense when you see it. So I've written this out. If stormtroopers shoot rebels, then Ewoks eat Jawas. If Darth Vader doesn't force choke, then Jar Jar Binks acts annoying. If Darth Vader does force choke, then Ewoks don't eat Jawas. Okay, so we need to conclude something from this. So we're going to actually, just to make our lives easier, because they're all set up as if-then statements, so we're going to abbreviate and use single or just two letters. So the first one is if S, then E, for stormtroopers, then Ewoks. The second one is now doesn't, or you could read that does not. So we say DV, the negation of that. So not DV, then JJ. And then if it does, that is DV. So that's a positive statement. Then, okay, that's a negative statement. Then not E. So that's the way it reads right now. So to remember the chain of reasoning, it basically has to kind of like take this form to it. Okay, you have to have a start and it has to zigzag until you get to the end. And each one of these, like these would have to match up, and then whatever this is would have to match up. So the first one, you always keep the first one the same. Okay, you don't want to change that. So leave the first one the way it is. Now the second one, we're going to rearrange it and rewrite it. Because remember, we started off with this, so this next one needs to start with an E. Well, the only other E was the negation of an E. But because of the contrapositive, remember a contrapositive is always true. So with a contrapositive, you can flip this statement. Okay, so the first thing you do is flip it if you want to look at it in steps. And then the second thing you would do is negate both of them. So that's how we get to here. Okay? Now, we have a not DV right there, so we're going to move that one to the last. So now we have a chain of reasoning. We've rearranged it and just used the contrapositive of this one. So we're going to look at this. What did we start with? What did we finish with? We started with S and finished with JJ. Therefore, if S, then JJ, which means, hence, if stormtroopers shoot rebels, then Jar Jar Binks acts annoying. Little confusing. It's not going to necessarily be something that you're tested on. It's just kind of meant to get you into the mindset of how proofs work. So if you're having a hard time understanding this, we'll go over it in class and we'll spend some time on it. But we're not going to spend days on it because it's really there just to get you into a mindset. So that's all. Look for more videos this week and have a good evening.